Hello and welcome to Earthquake Tip number 16. My name is Shailesh Kumar Agarwal, Executive Director of BMTPC, and I'm going to present to you all about earthquakes, its concepts, terminologies, and how to construct buildings and structures to withstand earthquake forces through 32 earthquake tips, which are authored by Professor C.V.R. Murthy, mentored by Professor Sudhir Kumar Jain, and developed by IIT Kanpur in association with Building Materials and Technology Promotion Council, that is BMTPC. Through these days, our aim is to spread right technical information in simple to understand language to our professionals who are in the field designing and constructing structures, especially architects and engineers. But before we start, let's make a pledge that any new structure we design or build must be earthquake resistant. This earthquake tip number 16 will explain you how to make stone masonry buildings earthquake resistant. In earlier tips, we studied brick masonry buildings, which is the most prevalent building typologies being practiced in our country. However, stone has been used in building construction in India since ancient times as it is locally available and durable. There are huge number of stone masonry buildings in the country, ranging from rural houses to royal palaces and temples. In a typical rural stone house construction in India, the stone masonry walls are normally quite thick, the thickness ranging from 600 mm to 1200 mm. These walls are built using rounded stones from river beds with mud mortar. The walls are constructed generally with stones placed in random manner and hence do not have the usual layers or courses as seen in brick masonry walls. These uncoursed walls have two exterior vertical layers called leaves or whites of large stones filled in between with loose stone, rubble, and mud mortar. A typical uncoursed random stone masonry wall, also known as UCR masonry wall, is shown in this figure. In a typical rural house, these walls support heavy roofs which may be of timber with thick mud overlay or a wooden truss with tiles, or it can be usual cast in situ RCC slab. These stone masonry construction with large wall thickness and robust appearance because of stone may be considered safe by general public, but this is not the case. These buildings are one of the most efficient building system for earthquake resistance point of view. Let me tell you the main deficiencies of these construction. Number one, excessive wall thickness. Secondly, absence of any connection between two outer layers, that is whites. Thirdly, use of round stones instead of shaped stones. These buildings have shown very poor performance during past earthquakes, not only in India, but also in other countries as Greece, Iran, Turkey, and former Yugoslavia. Let me show you this picture of 1993 Khilari, that is Latur, Maharashtra earthquake, where more than 8,000 people lost their life on account of failure of traditional stone masonry buildings. Also, during 2001 Bhuj earthquake, a majority of over 13,800 deaths is attributed to collapse of stone masonry construction. As you can see in this figure, the main patterns of earthquake damages include bulging or separation of walls in the horizontal direction into two distinct Y's, separation of wall corners and T-junctions as shown in this figure 2b, separation of poorly constructed roof from walls and eventually collapse of whole dwelling. The next question comes to mind, that how to make these stone masonry construction earthquake resistant. First of all, let me tell you, low strength stone masonry buildings are weak against earthquakes and should be avoided in high seismic zones. There is Indian standard IS 13828 1993, which stipulates that inclusion of special earthquake resistant design and construction features may enhance the earthquake resistance of these buildings and reduce the loss of life. However, in spite of earthquake resistant features, these buildings may not become totally free from heavy damage and even collapse in case of major earthquake. The contribution of each of these features is difficult to quantify, but qualitatively, these features have been observed to improve the performance of stone masonry buildings during past earthquakes. Let me explain you these earthquake resistant features one by one. The first one is ensure proper wall construction. That means the wall thickness should not exceed 450 mm. Round stone boulders should not be used in the construction. Instead, the stone should be shaped using chisels and hammers. Use of mud mortar should be avoided in high seismic zones. Instead, cement sand mortar should be 1:6 or richer, and lime sand mortar 1:3 or richer should be used. Second is ensure proper bond in masonry courses. As you can see in this figure, the masonry wall should be built in construction lifts not exceeding 600 mm. Thorough stones, each extending over full thickness of wall, or a pair of overlapping bond stones, each extending over at least 3/4 the thickness of wall, must be used at every 600 meter along the height and at a maximum spacing of 1.2 meter along the length. The third feature is provide horizontal reinforcing elements. As you can see in this figure, the stone masonry dwelling units must have horizontal bands. Remember earlier tip on horizontal bands, namely plinth, lintel, roof, and gable bands. These bands can be constructed out of wood or reinforced concrete. It is important to provide at least one band, either lintel band or roof band in stone masonry construction. The fourth feature is control on overall dimensions and heights. The unsupported length of walls between cross walls should be limited to 5 meter. For longer walls, cross support raised from ground level called buttress should be provided at a spacing not more than 4 meter. The height of each story should not exceed 3 meter. In general, stone masonry buildings should not be taller than 2-story when built in cement mortar and 1 story when built in lime or mud mortar. The walls should have a thickness of at least 1/6 of its height. Although this type of stone masonry construction practice is deficient with regard to earthquake resistance, its extensive use is likely to continue due to tradition and low cost. But to protect human lives and property in future earthquakes, it is necessary to follow stone masonry construction as I have described you in this tip, especially ensure proper wall construction and ensure proper bond in masonry courses for seismic zones 3 or higher. Also, the use of seismic band is highly recommended. That's all about earthquake tip number 16. You can download the tip from www.bmtpc.org. The next earthquake tip number 17 will be on how do earthquakes affect reinforced concrete buildings. Thank you.